Hey, sixth grade, you have a short screencast today because I want to make sure that you get a lot of really meaningful group practice. So our title is Comparing Ratios Using Ratio Tables, and our objective is I can solve problems by comparing different ratios using two or more ratio tables. So this chunk here will be what we cover together in the video. The rest of this page will be your group practice problems, and then your exit ticket will be on the next page. So we really just need to focus up here. Create 4 equivalent ratios, 2 by scaling up and 2 by scaling down using the ratio 30 to 80. So we're starting with this. They want 4 equivalent ratios. 2 of them need to be larger and 2 of them need to be smaller. So I'll use 2 different colors to show my 2 larger and then my 2 smaller. If I'm making equivalent ratios that are larger, I need to multiply by the same thing on each side. So here I'll multiply by 2, and here I'll multiply by 10. I could multiply by 3 or 4 or whatever I desire. So 3 times 2 is 6, and there's 1 0. 8 times 2 is 16, and there's 1 0. So 30 to 80 is equivalent to 60 to 120. I'm sorry, 160. 30 times 10 is 300, and 80 times 10 is 800. So now I've created 300 to 800, 60 to 160, and those are my 2 equivalent ratios that scale up, that are larger. Now the 2 that I scaled down will be equivalent ratios that are smaller. So if I'm making them smaller, I have to divide by the same thing on each side. So here I'll divide by 10 and I'll divide them in half, so by 2. So 30 divided by 10 is equal to 3. 80 divided by 10 is equal to 8. 30 divided by 2 is 15, and 80 divided by 2 is 40. So now these are my 2 equivalent ratios that have been scaled down. That means 30 to 80, 60 to 160, 300 to 800, 3 to 8, and 15 to 40 are all equivalent ratios. The key is really making sure that you're multiplying by the same thing on each side or dividing by the same thing on each side and being accurate with your math facts. Okay, and so the last problem that we're going to do together is write a ratio to describe the relationship shown in this table. So we see the hours and then the number of pizzas sold. So when 2 hours have gone by, a pizza store has sold 16 pizzas. When 5 hours have gone by, the pizza store has sold 40. So I'm looking for a relationship across and down to see what I can come up with. I can use some of the values that they gave me, right? So for every 2 hours, 16 pizzas have been sold. For every 10 hours, 80 pizzas have been sold. But I can also use scaling up and scaling down to help me. So I can divide each of these by 2. 2 divided by 2 is 1, and 16 divided by 2 is 8. So here's a ratio that makes sense for the table. Roughly every hour, 8 pizzas are sold. I can also see that pattern really clearly here. So instead of dividing by 2 on each side, I can use this number, or this ratio from the table, and divide each side really easily by 10. And I see the exact same pattern. 10 divided by 10 is 1, and 80 divided by 10 is 8. So we get the same ratio, 1 to 8 and 1 to 8. I could also scale up. Scaling up probably wouldn't help me as much because then I can't figure out how much they need per, or how many pizzas they sell per hour, but they don't necessarily ask for that here. So you could have a ratio of 5 to 40, 6 to 48. 1 to 8 is probably the most meaningful ratio you could write. You could generate a lot of other equivalent ratios, but this one will probably help you in problem solving the most in typical math problems. All right, so the exercises on the bottom here will be for you to do with your group. And then finally, your exit ticket will be on the back. Thanks so much.